Hi students. In the previous class, we have studied about spherical mirrors and the two types of spherical mirrors we have. Those are convex as well as concave mirrors. We have seen what are the technical terminologies that we are going to use like pole, center of curvature, radius of curvature, principal axis, focus and focal length. In today's class, we are going to discuss about what are the differences between real and virtual images. We are going to see how to draw the ray diagrams for the convex as well as concave mirrors. See, the main thing about real and virtual images. Many students are going to get confused here. See, what is the meaning of virtual image? If you are going to stand in front of a mirror that is in our home, then where you are going to find your image? The image is appeared to be coming from behind the mirror. That means, okay, this is the mirror and a person is standing here. He is going to find himself here, the back side of the mirror. Am I right or wrong? Such images are what we called as virtual images. Means virtual images are those images which are going to be formed behind the mirror, and always you are going to find erected image, means upright. You are going to find image like this. Okay, real images are those images which can be caught on the screen. That means they are not the type of images which are going to be formed behind the mirror. So real image will be formed something like this. So real image is always inverted, virtual image is always erected. So you have to understand this. And real image can be caught on the screen, whereas virtual image cannot be caught on the screen. So here we are going to understand the difference in a tabular form. So now we are writing the differences between real and virtual images. So point number 1 is real image can be caught on the screen. Here first point, virtual image cannot be caught on the screen. And the second point is real image is always inverted, and the second point here is virtual image is always erected. Okay, these are the important differences between real and virtual images. So these are the differences between real and virtual images. So real image, okay, which can be called formed real image, the plane mirror will form a virtual image, and convex mirror can form a virtual image. Concave mirror can form real as well as virtual images. Okay, if you are standing in front of the mirror and you can able to see yourself in the inside the mirror, then that image is what we called as virtual image. So virtual image can be formed by what type of mirrors? Plane mirror and convex mirror. Both are capable of forming virtual images, whereas concave mirror can form real as well as virtual images. So now we are going to see how to draw the ray diagrams for the spherical mirrors. See, first of all, we are going to discuss about concave mirrors, how to draw the ray diagrams for the concave mirrors. See, for drawing ray diagrams of the concave mirrors, we are going to have some rules. Okay, see, this is a concave mirror, and you all know where pole is located. The pole is located here. This is P, this is F, and this is C. This is pole, focus, and center of curvature. These are the 3 points we have. See, this is the incident ray. Now, can you please tell me? The incident ray is just parallel to the principal axis. This is the incident ray. The incident ray is drawn parallel to the principal axis. Now we have already discussed that this is what we called as the tangent, and here this is what we called as normal. This angle is called as angle of incidence, and the reflected ray should have to pass through F is our first rule of drawing the ray diagram. Then this is going to become angle R. So what is our first rule says? First rule of drawing the ray diagram says that if the incident ray is parallel to the principal axis, then reflected ray should pass through F. I'm saying once again, if the incident ray is parallel to the principal axis, then reflected ray will be passing through F. And you all know that normal always intersect at C. Now we are going for the second rule of drawing the ray diagram. Okay, this is the concave mirror, and this is the principal axis. This is P, F, and C. Now the second rule says if the incident ray passes through F, then reflected ray will be parallel to the principal axis is our second rule of drawing the ray diagram. This is our reflected ray. Now this is our incident ray and this is our reflected ray. If the incident ray passes through F, then the reflected ray will be parallel to the principal axis. That is the converse of the same statement. The first statement and second statement are converse of each other. Okay. If the incident ray, here look at this situation. If the incident ray passes parallel to the principal axis, then reflected ray will be passing through F. Look at the second condition. If the incident ray passes through F, then the reflected ray will be parallel to the principal axis. Now let's see the third condition. What is our third condition of drawing the ray diagram? See, this is our concave mirror. This is the principal axis. This is P, F, and C. Pole, focus, and center of curvature. Now, if the incident ray passes through principal axis, then the reflected ray will be bouncing back onto the principal axis. That means this is our incident ray. This is our reflected ray. Exactly on the same line in the opposite direction. Now the fourth rule says that this is our concave mirror. Now this is the principal axis. This is P, F, and C. If the incident ray passes through C, then reflected ray bounces back onto the C. If the incident ray, this is our incident ray and this is our reflected ray. If the incident ray passes through C, then the reflected ray also bounces back onto the C. Now we are at the last condition, that is our fifth condition. This is our concave mirror. Now this is the principal axis P, F, and C, and this is the incident ray which is making an angle I with the pole. Then the same I is going to be made here on the reflected ray. That means angle I is equal to angle R. Now this principal axis itself behaves like normal. Okay, these are the 5 rules of drawing the ray diagram. I'll repeat once again. If the incident ray is parallel to the principal axis, then reflected ray should pass through F. If the incident ray pass through F, then the reflected ray will be parallel to the principal axis. Rule number 3, if the incident ray passes through the principal axis, then reflected ray will be bounced back onto the principal axis. Rule number 4, if the incident ray passes through C, then the reflected ray bounces back onto the C. Rule number 5, angle of incidence which is made at pole is equals to angle of reflection which is made at pole. So that means at the pole, angle I is equal to angular. At every point that is the same, but these are conditions which are going to be useful while you are going to draw the ray diagrams. While we are going to draw the ray diagrams, we can understand all these situations and it will become easy for us to understand more about drawing the ray diagrams. So ray diagrams are the things. So what is the important use of ray diagrams? What we are going to get while drawing the ray diagrams? See, when we are going to draw the ray diagram, we can understand the position of the object respective to the position of the image, where the object is placed and where the images are going to be formed and what type of images we are going to see, that can be seen by having ray diagrams. So these ray diagrams, for the concave mirrors, we are going to have 6 ray diagrams. That means 6 conditions are there. For the convex mirrors, we are going to have 2 conditions. So first we will discuss about the conditions for the concave mirrors. So this is a concave mirror. Now we are going to see where we can place the object in front of the concave mirror. This is P, F and C. See, we can place the object at the first condition is we can place it at infinity. That means like sunlight, moonlight, very larger distance. That is what we called as a first condition. You always remember, if the source is infinity, then the beam of light is called as parallel beam of light. Parallel beam. Okay, not chota beam, parallel beam of light. So when the light ray is coming from infinite source like sunlight, it is taken as parallel beam of light. This is the first condition. Second condition, we can place the object beyond C. We can place the object beyond C. Third condition is we can place the object exactly on C. Fourth condition is we can place the object between F and C. Fifth condition is we can place the object exactly on F. And sixth condition is we can place the object between P and F. So these are the 6 different conditions for a concave mirror. I am writing here. Those 6 conditions are: you can place the object at infinity. Second condition is you can place it at beyond C. Third is you can place it on C. Fourth is you can place it between F and C. Fifth is you can place it on F. And sixth is you can place it between P and F. These are the 6 conditions are there for the concave mirror. For the concave mirror, this is about concave mirror. For the concave mirror, you can place the object at 6 different conditions. And 6 different conditions will have 6 different ray diagrams. Now we are going to see how many conditions are there for a convex mirror. For a convex mirror, I told you already, we have only 2 conditions. The reason for it is, see, look at the structure of convex mirror. See, this is P, F and C, and this side is silvered. That means when you have to place the object, you have to place the object on this side, not on this side. This side we can't place the object, this we can place the object. That means you have no conditions like beyond C, on C, between F and C. All these conditions does not exist. Here the only 2 conditions we have is, the first one is we can place it at infinity. The second one is we can place it between infinity and P, anywhere. So the 2 conditions are, first one is at infinity, we can place it at infinity. Second condition is between infinity and P, anywhere. The matter is same, because it is, the F is not on this side, C is not on this side. That's why we can place the object anywhere. So these are the 6 conditions are there for the concave mirror, as well as 2 conditions are there for the convex mirror. So by having these 2, we can understand the position of the object with respect to that, how we are going to have the images, what is the nature of the image, what are the characteristics of the image which are going to be formed. We are going to see in the next class. Thank you.